everyone! Today we're going to continue on with naming ions. And if you remember in the last lesson, we focused on monoatomic ions, also known as ions that have one atom. Today we're going to focus on polyatomic ions. So poly, we're going to learn, means more than one. And since they're ions, they're going to have a positive and negative charge. So let's talk about how do polyatomic ions differ from monoatomic and how are they similar. So unlike a monoatomic ion, a polyatomic ion is composed of more than one atom, and that becomes important for you guys being able to recognize them. However, just like a monoatomic, polyatomics behave as one single unit and they carry a charge. So they can be positive or they can have a negative charge. Here are some common polyatomic ions. For example, ammonium ion, nitrate, sulfate, or phosphate. Notice that if we look at their formula, they have more than one atom. Ammonium is made up of nitrogen and hydrogen. And here, this tells me I have a +1 charge. Nitrate is made up of nitrogen and oxygen, and this negative tells me it has a -1 charge. Sulfate is made up of sulfur and oxygen, and this has a 2 negative charge. And phosphate is made up of phosphorus and oxygen and has a 3 negative charge. Now, if you're confused by this little number down here, that, remember, just tells me how much of each element that I have. So in an ammonium ion, there are 4 hydrogen. Here, this is the chart that I've actually given you in your notes, and this is the chart I will give you on your test. You do not have to memorize these, but it's nice to become familiar with some of the common ones that you're going to see on your homework. Specifically, I really like to use these 5 right here: perchlorate, chlorate, chlorite, and hypochlorite and cyanide. I also like to use hydroxide. I also like to use these 3 quite a bit: hydroxide, nitrite, nitrate. And then I like to use carbonate, sulfite and sulfate, and then these ones down here. Notice that most of your polyatomic ions get a negative charge. There's actually one positively charged polyatomic that we use, and this one, ammonium down here, is really the only positive one that we like to mess with. The other thing that I want to point out is notice that most of them end in ate or ite. And down here, the only ones that don't end in ate or ite are the ones that are bolded. So hydroxide, cyanide, and ammonia are 3 common ones that we will use that do not end in ite or ate. So like I've just stated, many of them end in ite or ate, and that's because sometimes the same 2 or 3 elements combine in different ratios. All it means is the ite usually has 1 less oxygen than the ate. Let's go back and look at some examples. Here we have sulfur and oxygen, and they're combining 2 different ways. This one has 1 sulfur with 3 oxygen, and this one has 1 sulfur with 4 oxygen. Notice the one that has more oxygen ends in ate, and the one that has less ends in ite. If we go over here to phosphite and phosphate, notice they are both phosphorus and oxygen, but the ate has 1 more oxygen than the ite. One thing I don't want you to get confused about is ite does not equal 3 oxygen, and ate does not equal 4 oxygen. It just tells me the relative number of oxygen. So let's look over here with these 2. This one ends in ate, but notice the oxygen is 3. This one ends in ite, and notice the oxygen is 2. That's okay because the ite and ate just tells me one less or one more oxygen, not the specific number. Now that we've talked about polyatomics, I told you I'm going to give you the chart. Let's talk about why are they important? Why do we care about learning about them? Well, hydrogen carbonate, which is an anion, it's a polyatomic, and hydrogen phosphate, this is a polyatomic. Dihydrogen phosphate, another polyatomic. All of these are important for living systems. We need these in order to survive. We know that these are polyatomic because there are 3 elements here and there's a charge. This one has 3 different elements and there's a charge, and this one has 3 different elements with a charge. These ions are actually important for living systems because they are crucial because they are dissolved in your blood and allows your body to function properly. Sodium hydrogen carbonate is HCO3 with a -1. This is an important polyatomic to relieve an upset stomach. And then in contrast, cyanide, this is a polyatomic because it has 2 atoms, carbon and nitrogen. This is extremely poisonous and dangerous. And the reason it's so dangerous is because it blocks the cell's ability to produce oxygen. If you remember from biology, produce energy. If you remember from biology, instead of oxygen being at the end of your electron transport chain of cellular respiration, cyanide actually takes its place, and therefore you're not able to get energy or produce it. And that is needed to be able to function as a living human being. And that's basically the end of section 1, naming ions. If you have any questions whatsoever, please make sure that you reach out to me, and I hope you guys have a great day.